Please welcome Adam Gołębiowski.
Hi everyone. Well, I would like to start with a warning that this presentation is going to contain some significant amount of source code. So if you would like to, you can open this webpage on your smartphones and enjoy some additional content, annotations, and hyperlinks. But this is purely optional. You can scan the QR code or just use the address. In the meantime, I'll figure out how to use the clicker.
Do you want me to click that? You just give me a nod and I can click it for you. Let you concentrate on the talking.
Okay, okay, so if everyone is ready, today we will start with some examples showing what code contracts are and how they look like. Then I'll awesome why code contracts are so awesome, what is their history, and I'll explain the inner workings. We will go contract by contract explaining how this one works and is implemented internally. I have also one question. Does anyone here knows any object-oriented language? Okay, great. So how many of you are programming in test-driven development? Okay, so even those who don't would probably agree that unit tests are necessary in any industrial project. They are very handy because they ensure that your code is executed in controlled environment and works as expected for example inputs. But do you think that that unit tests are enough? Let's see this example interface in C#. We have to do something with it. We have to extend it, debug it, write implementation, doesn't matter. What does matter is that for some reason we don't understand what its methods are really supposed to do. It may be because of obscure naming convention, use of many acronyms in them, or lack of domain knowledge. To be honest, sometimes while working at Nokia, I was worried that to understand some method names, I had to use not our abbreviation glossary, but Finnish dictionary. For help, we have unit tests. There are no unit tests for interface, but you can hopefully find some implementation and unit tests for that implementation in hope that they will help you understand what the interface was supposed to do. But does it always work? We can see here this example test suite that checks two methods from this interface using example inputs and outputs. But if we haven't already understood what it's supposed to do from names, this test isn't going to help us much. We can see that it operates on some numbers. We can see example inputs and outputs. But is this really a compiled form of specification we want to have? It's very hard to write unit tests in such a generic way. It will always be possible, no matter how many examples you will give in unit tests on how to use your methods, it will always be possible to write implementation that will pass those tests, but will fail on other cases and bugs will slip through. You didn't really understood the intent behind the inner working of method. Let's see how contract looks like and whether it will help us guess what was the intent behind those two methods, even if we don't understand their names. We can see that first method requires some positive number on input and returns Fibonacci number because we know that it ensured that result is Fibonacci number and that there will be exactly n Fibonacci n such a numbers between 0 and our result that are Fibonacci numbers. So we know that this method, in fact, returns us nth Fibonacci number. It wasn't...
May I ask a question?
Sure.
Thanks. And does it mean that's behavior-driven development? Because there we can see that some set of rules which we expect from this method.
Exactly. These are our exact expectations written in generic way about how we expect this method to behave. It describes outer behavior that can be seen by us and what is expected from us as users. So we both know how to use it. We know that the only thing that we can pass as a parameter is a positive integer. And as you said, we know how it will behave. It will give us nth Fibonacci number. And let's see second example. This time method requires us to pass some Fibonacci number to it. We check that parameter is a Fibonacci number. This is a requirement. And what this method guarantees? It says us that result will be bigger than what we gave. It also will be Fibonacci number, so it will be another Fibonacci number bigger than the input. And there will be no Fibonacci numbers between our input and output. So what does this method do? Does any of you can guess? Gives us bigger Fibonacci number than we gave, and there are no Fibonacci numbers between. It gives us next Fibonacci number. So without knowing from any specification what those methods are expected to do, we've compiled code contract that we know for sure will have to be valid with any implementation. We understood what was the precise intent behind the interface, even without example inputs and outputs. As you can see, as opposite to unit tests, contract was exhaustive and ambiguous. There was no way to write implementation that would pass the contract but fail in some practical real-life case. And it was possible with unit tests. It was possible to write implementation that would pass those 3 example inputs, but will fail in any different, or in some different that we don't thought about. With contract, you can be sure that if it passes those rules, it's okay. Let's compare. Yes?
Sorry, quick question. What effect does that have on, or impact on your exception handling in your actual kind of class? I mean, I'm assuming you would have to do less exception handling because the contract is kind of preventing or controlling those inputs for you.
It depends how you will configure contracts, because contracts are configurable. You can run them with your production code in such a way that it will throw exceptions for you when your code is used in wrong way. So you will no longer have to code in right defending code, so-called.
Yeah.
So you will not have to validate your inputs, because contract will do it for you and throw appropriate, for example, argument exception. They are very smart and they are suited for exactly this case, to simplify your life. Let's compare some features of unit tests and contracts. As you have seen, unit tests always check specific usage examples. On the contrary, contracts specify full generic requirements and the intent behind some method. Unit tests can only check public methods, what I think is good, but contracts can be defined on any method. So you can have your internal contracts on a private method that will also help you ensure that they are written in proper way. And they are easier to write than unit tests, so it's not much more work if you do this also on private methods. Unit tests have to be run explicitly. And one might think that this is enough, but on the other hand, contracts are run both during unit test session, but can be also validated with static analyzer, run on production, or with debugging mode. Unit tests have convention that each unit test checks some execution path of some method. Code contracts doesn't need such convention because each one is syntactically bound to exactly one method. So you always can be sure that one method has one contract. And you never have method that you are not sure whether are contracted, or you never have contract that doesn't have method to check. And they always cover full method because they don't operate on examples that can go through one execution path or another.
Sure. So, but for unit tests, we can create a lot of unit tests for one method.
Mm-hmm.
We can check a lot of different cases because, as usual, our method that's not only one operation. So it has a lot of steps and some, let's say, algorithm. And depends on the input parameters, we will have the different results. And in case of contracts, does it mean that I can also create a lot of contracts or contracts method?
You write only one contract per method,
Okay.
but you can write it in a way that will cover all execution paths at once. In the extended version of this example that can be seen online, because the version on the slides is somewhat shortened, you can see that one of those actually covers something like 2 execution paths, because for 0 and 1 Fibonacci number is calculated in different way, and it's trivial to say using Boolean expression that says that this contract will have to be checked only if parameters was such, and this part of contracts will have to be checked if parameter was such. So you can join contracts for multiple execution paths in single contract.
Okay, thanks.
There is two more differences. Unit tests can only target specific class, the implementation. Contract, on the other hand, can target whole interface. If you write contract for interface, it will be validated for all the classes that are supposed to implement that interface. So you don't have to create things such as some class test base that is later inherited by test suites that check the classes that have to have the same behavior. You write it only once, and there is no explicit inheritance later. What's more, unit tests can only check post conditions, and contracts can also check whether your code was used by someone in a proper way. So if the unit test won't help you detect that someone used your method with illegal arguments, or when the object was in state that is illegal to call this method. And contract will detect this and report. So you might wonder, since we can specify those of some sets of requirements, we have to develop some tool that will check them for us. But if you're using full .NET framework, the tool is already there. Contract programming began with Eiffel language that had syntactic constructs for specifying postconditions, preconditions, and invariants. I've also seen contracts in object constraint language. Has anyone heard about it? It's part of UML by Object Management Group. It's also a language that helps you specify preconditions, postconditions, and invariants, but they cannot be joined, merged in implementation, so it's writing just for writing. You cannot easily check them. And Microsoft wrote a framework and toolset that helps to use such a contracts with any language from .NET family, for example C#. They were designed at Software Engineering Division of Microsoft Research. They were designed to improve testing, the generation of documentation and static analysis, and at first released commercially, but later open sourced and released on GitHub. They are part of base class library, were used in implementation of .NET Framework and .NET Core, but unfortunately for foreseeable future, Microsoft does not plan to develop .NET Core compatible toolset. The toolset contains of 3 packages. There is documentation. There is one which contains everything: documentation generator, rewriter that is needed to check contracts at runtime, and static analyzer. There is Visual Studio extension, but it's incompatible with .NET Core and Visual Studio 2017 and up. There is another package, System Diagnostics Contracts, that is written especially for .NET Core, but contains their stubs interface. So it lets you declare contracts, but there will be no way to check them under .NET Core, just under the full .NET Framework. And there is also good news: we can develop as a community toolset for .NET Core, and we already know how. We just need people that will be willing to do so. This is how core interface of code contracts look like. It's contained both in the standard library of .NET Framework and in the package System Diagnostics Contracts for .NET Core. There are merely few assertion and helper methods, and all of them are empty. How they work. When runtime checking is off, they do nothing. I omitted it on previous slide for brevity, but all of them are marked with conditional attribute. So if you are building for production, they will be completely omitted. There is no performance overhead from using code contracts. If you are using them in a proper way, they will do exactly nothing unless you want to turn on runtime checking before build. First way of validating your contracts is static analysis. When writing code in Visual Studio and building, the extension will report any places where contracts may be violated. Code is not run for that, so it may only report some kinds of violations, and you will see that in practice some of them would never occur. But the good side is that it's very smart. It will report even contract violations for contracts you have not defined yet, and it will tell you that you should define some contract. And the cases that are missed by it can be spotted by runtime checker. To turn on runtime checking, you need to somehow transform contracts from their declarative form to the actual checking code and assertions similar to ones that you're using with unit tests. For that, you need to use a tool called Contract Rewriter that is within the toolset. It takes your compiled binary assembly and transforms its IL code, which is .NET equivalent of assembly language. It injects one class contracts runtime into it and replaces all the calls to stub methods in contracts class to calls to contracts runtime. And it additionally passes string representation of expression you wanted to check to those methods, so that when the contract is violated later, in the exception you will see nice message saying what go wrong. There are few methods that have more complex transformations because of their nature they need to change control flow of a method, and some of them are just simply transformed. There is another class called. So without running a writer, your assembly will have no performance overhead, there will be no runtime checking, and when you run a writer you will have secure assembly with contracts that may run slower but will report you any violations. Contract requires, assert, and assume are the simplest contracts. They undergo no additional transformations except what I already said. Requires is just a precondition. It can check whether the parameters are okay or if the method isn't called in a state that is illegal for it. Ensures on throw is a postcondition regarding what method guarantees if there will be an exception of given type thrown from it. So to check it, the writer has to wrap whole method in the try block and inserts the checking code into the catch block of it. And this is all. The writer ensures. Ensures is a simple postcondition. It says what method guarantees about its result or state of the object after it was called. Because it has to be checked at the method exit, the control flow is transformed in such a way that there is just single return statement at the end of the method, and that ensures contract is moved just before it. Result is a helper method that helps you specify the postcondition regarding value returned from the method. There is some time manipulation magic involved because you write that contract at the top of the method, but you want to say what the result will be when this result is not even declared yet. But since you already know that ensures is moved to the end of the method, this becomes trivial because we are already at the end of the method and we have generated variable result. It's enough to replace contract result with variable result. Value of return is helper method very similar to result in both implementation and meaning. It just means value of some expression at the end of the method. We specify it at the top of the method, but since ensures is already moved to the bottom and we can only use this inside ensures, we can just replace value at return with the value that we wanted to have, because we are already at return, literally. Invariant is some contract that has to be obeyed by instance all the time, except during method calls on it. In practice, it's enough to check the invariance at the end of each public call, and this is what happens. Call to contract checking method is appended to end of each public method, and it guarantees that your state will be valid all the time. Contracts also give us two additional attributes. First of them is contract class 4 that allows you to declare contracts for interface, because usually you specify contracts in the body of method at the top, but interface methods cannot have any body. So as you have seen in the examples on the beginning, I have declared another abstract class that is contract class for the interface, and contract writer will know that it has to copy content of all the contracts to each implementation and then check it. And the last one is contract abbreviator that lets you bundle few contracts in a single method and then reference it from particular methods in your implementation, so that they can share a single contract without duplicating it. And it just gets inlined there. Okay, so we can already have our contracts checked, but what happens when one of them is violated? As I mentioned, there is contracts runtime injected into assembly and referenced by code generated by contract writer. When any of the checks detects that expression passed to it evaluates to false, it calls all the event handlers registered on contract failed event. Those handlers can be registered by you as a developer, for example, to fail an unit test or log that contract is violated to log4net or some other logging output. But there can be also some handlers registered by runtime. For example, to display message to the user of interactive shell or whatever context your code is running in. Any of those handlers can set handled on the event so that there will be no additional consequences. But if no of them does this, the contract exception is thrown, which contains nice string representation of expression that evaluated to false, so that you will exactly know what went wrong in which method. As I said, you can only validate your contracts using full .NET for .NET Core by ourselves. There are a few ways to do this. The simpler one would be to do transformations on the source code, and for this we can create the preprocessor based on Roslyn platform, which is open source C# compiler infrastructure delivered by Microsoft. And it gives us a tool called C# syntax rewriter. This is a class which implements visitor pattern and visits every node of given type in syntax tree of code, and optionally lets you replace some of them by another version. And we would like to do similar transformations that were already done by contract writer from Microsoft. So here, we first have to say what is a contract call. For that, we need to visit every invocation in the code and check whether it calls some contract.something method. For this, we need to compile code in the memory and use semantic model to know what is the class that method is called on. And when we already know that something is a contract, instead of returning original node, we return rewritten one. To rewrite it, we use such a method. This does just two things. Change just the class, this is called on, to the contracts runtime, which has the actual checking code, and adds the additional parameter with string literal. How does it work? You can see that we are extracting alt reference to the class, this is called on. We extract the Boolean expression that was passed. For example, n is greater than 0, and we create string literal from it, from its text. And we replace the node responsible for the class by taking full name of contracts runtime class and creating invocation expression from it. For the more complex contracts, you will also need the code that changes the method body, but this is enough for the simplest ones. Once you already know what contracts are and how to use them, I encourage you to check out those documentation links. And for those that would be willing to help with creating implementation for .NET Core, the last one is especially interesting because it leads to a library called Fody that lets you manipulate not the source code, but the compiled assembly in exactly the same way as original contract writer did. And that's all. Thank you for your attention.